Okay, so now we're going to do gravitational fields. And the formula for gravitational fields actually is in the data packet. I don't know why the electric field one isn't. But anyway, the gravitational fields are easy. They're just toward the mass, right? So the gravitational field of B is toward B, wink, at point P. So here's G, B, right? And then the G due to A is toward A, right? 2, 2. So it's like this. Here's the G of A. So we don't have to worry about positive and negative charge, which is kind of nice. It's just toward these guys, right? Okay. And then, these are quite massive because we want nice numbers for our gravitational field. So the first thing I'm going to do is I'm going to find the gravitational field due to A. Okay, so this thing is going to be big GM over R squared. So 6.67 E minus 11. And then the mass of A is 9.4. E12. And then how far are we from A? We are 2 over and 1, 2, 3, 4 down. 2 over and 4 down. So it's going to be 2 squared plus 4 squared. And of course it's the square root of that. But then of course it's squared. Oh, the square root goes away. All right, so let's figure this out. I'm going to go alpha F1 and grab that fraction thing and go 6.67 E minus 11 times, let's see, A is 9.4. E12, and then we're going to divide by 2 squared plus 4 squared. That's just 20, isn't it? All right, here we go. 31.349. And that is newtons per kilogram. Oh dear, okay, so what kind of angle is that? Let's figure this angle out. This thing is to the down and to the right. And that angle right there is, what is it? I guess it's, if we draw this whole triangle here, right? If the angle here, this side is 4, this side is 2, so it's the inverse tan of 4 over 2. So what is the inverse tan of 4 divided by 2? Same as the inverse tan of 2. That's 63.43. So many angles are 63.43 in these complicated times. Degrees. So this is 63.43 degrees below the x-axis. All right. Belokes. All right. There we go. Did we do that right? Seems like we did. Yeah. All right. So now let's find the gravitational field due to B. And that's going to be the same thing, GM over R squared. So 6.67 E minus 11. And then B is just 1.8 times 10 to the 12. What is that? Is that tera kilograms? I don't even know. What is it? Yeah, I can't even go there. Okay. So 1.8 E12. And then divided by how far away? We're 2 over 2 down, so that's going to be 2 squared plus 2 squared. Okay, so let's go find that thing. I just got it. 2 squared plus 2 squared. So I changed the denominator. Now I just have to change the numerator. This guy's 1.8. Okay, so I've got it. Do I have it? I have it. Do I have it? I've got it. Boom. 15.0075. And that's newtons per kilogram. And this guy is left and down. And this angle is, of course, our 45-degree angle. Alrighty. Okay, so now we're ready to Now we're ready to add them up, right? So let's go G in the A direction, I'm sorry, yeah, the gravitational field toward A, the G due to B, and then the sum. All right. Let's go X direction and Y direction. Denied. Tried to draw the straight line, I couldn't. All right, so let's keep these guys separated. Okay, so let's see. Here is our A vector, right? This has got a little bit of right. It goes to the right. And then it goes down like this. So this will be a positive component because it's to the right. This is going to be a negative component. Okay, and so this is going to be, A is 31.349. And then it's going to be cos of 63.43. Because it's the adjacent side, right? The x component touches that. So let's find that guy. Boom, cos, Betty boom. That's 14.02. 0.1969 or something like that. That's newtons per kilogram in the x direction. This will be 31.349. Is that what that was? Yeah. And this will be sine, because this is the opposite side, right? Sine of 63.43. So let's do that. I'm just going to grab that same thing and go. There we go, sine. This is 28.04 newtons per kilogram, and that's in the y direction. So notice that this is going to be down. Both of these, by the way, have a negative y component. This one also has a negative x component too. Okay, so we've got that. That looks good. More y than x. It all looks great. Okay, this guy is going to be, the b is 15.0075. And then the x component goes like this. There it is, and the y component goes like that. Okay, so the x is going to be negative, and the y is also going to be a negative component. All right, there we go. Okay, so 15, and then this will be, technically speaking, it's cos 45 degrees. Okay, it doesn't really matter because it's going to be the same. We could use sine or cos. So I'm going to grab that 15.0075 cos 45, 10.61. And this is, of course, the same thing, right? So 15.0075 sine of 45 is negative 10. Well, it's not negative 10.61. It's 10.61, but it's a negative component because this, we go to the left and then we go down, right? Okay, so now we're ready to add them up. We're going to add them like Bonica. Okay, so here we go. We got 14. Then we got to go minus this guy. 3.4077. 9. Look at that, newtons per kilogram. The x direction. So it's still to the right, but just barely to the right. Okay, and then these guys, let's see, this will be the opposite of 28.04, right? Plus the opposite of the 10.61 guy. I just love being able to go back up. So this is negative 38.651. So let's see, how do we draw this? This would be over just a little bit, down kind of a lot. So let's draw a picture of this. Over just a little bit. Down a whole lot, right? And the vector is this guy. Ooh, that was a really good job. It's a really bad job, but let's at least encourage me. So this angle right there, that angle is going to be inverse tan of 38.651 over 3.40779, all of that stuff, right? So second tan of that guy divided by this guy. That's 84.96. That'd be 85 degrees. 0.961 degrees. So I guess with 3 sig figs, you'd have to say 85.0 degrees is that angle right there. And then the magnitude of this thing is the square root of this guy, 3.4077 squared plus 38.651 squared. So I'm going to go square root. No, I didn't hit the square roots. Let's try it again. Square root, and then I'm going to grab that 3.4, sorry. This guy squared plus, oh, I got to use parentheses around this guy because it's negative. Boom, n parentheses squared. And it's 38.8. Isn't that funny? It's 38.7, right, with 2 sig figs. This ends up being 38.8 newtons per kilogram. There you go. So that's our magnitude. You've drawn a picture like this. It's down and to the right. You've labeled the angle. It's all hunky-dory. Okay? Wow, that's like a lot of work, isn't it? Think how smart you are, though.